The goal in this video is to share with you how you could determine a limit numerically. And these next things are, I don't want to call them steps, but are sort of guides for you, right? So if you're given a table of values, what you want to do is you want to look at the x values and see what those x values are approaching. I've got a couple of examples coming up so we can take a look at that. Next, or somewhere in there, you want to determine whether it's a one-sided or a two-sided limit. In other words, if it looks like the x values are approaching 3, are they approaching 3 from the right or from the left, or is it from both sides? And then finally, once you've sort of determined what's happening with the x values, look at what the y values are approaching. Whatever the y values are approaching, that's more than likely what the limit is going to be. So let's go on and look at the first example. So in this example, I want us to consider the table of values below for the function f of x. And the question is, what limit is being indicated by this table? So the first thing I want you to do is I want you to look at these x values here, right? Does it look like those x values, and this is important, either being read to the right or being read to the left? Does it look like they're approaching any number? So pause the video and think about that. From just look at the x values, does it look like the x values could be interpreted to be approaching something? So some people read this and say, well, you know, they read from left to right. You know, it looks like these are approaching 2.5. And I would say, in fact, these aren't approaching 2.5 because I even get to 2.5. When you're looking at a limit, we don't actually want to hit the number that we're getting to. So in this one, I think it actually makes the most sense to read this from right to left. And to say, you know, I started at 2.5, then I went to 2.2, then 2.1, then 2.01, then 2.001. And when you read it that way, it really looks like you're approaching 2. And so in this problem, what we're looking at is the limit as x approaches 2. Now, note, I'm not approaching 2 from both sides. Am I approaching 2 from the right or from the left? Well, if you sort of think about a number line, right? Imagine a number line here, and here's the number 2. If I started at 2.5, then went to 2.2, then 2.1, then 2.01, then 2.001, I'm approaching from the right. Now notice, the arrow is going to the left, but that means that I'm to the right of 2, and I'm going that way. So I'm approaching from the positive side, from the right side. So this is the limit as x approaches 2 from the right of the function f of x. So we've identified it's a one-sided limit. I'm approaching from the right. So now what you have to do is you have to look at the y values, right? As I read the y values in the same direction, does it appear that the y values are approaching something? So pause the video and think about that for something. Does it look like those numbers are approaching something? And I hope you recognize, you know, these numbers here are getting closer and closer to something like 15, right? Now, do I know the limit for sure is 15? No, not really. But that brings me to this next question. How could we further confirm this limit? Like, if you had access to the function, access to a calculator, what could you do to sort of confirm that this limit probably is 15? Now, pause the video and think about that. What we could do is we could plug in, an x value of maybe 2.0001. We could get even closer to 2 and find out what f of x is. If you were to plug in 2.0001 and found out that it was 14.9994, that would probably confirm your suspicions that, hey, as I got even closer to 2 from the right, my value, got even closer to 15. And so that leads us to the conclusion that what this table is telling us is that the limit from the right is 15. Okay? So another exactly the same problem, right? This time I want you to sort of look at this function, look at this table, and see if you can determine what limit is being indicated or not indicated. So pause the video and think about that. So the first thing I hope you were able to identify was what are we even approaching? When I do this limit, every limit is going to start the limit as x approaches something. So the question is, what is being approached? Right? And in this case, I hope you guys read it from left to right. It looks like this limit is approaching -1. Now again, is this a one-sided or a two-sided limit? Well, it looks like I'm approaching, and if you sort of think about the number line, here's where -1 is what we're trying to approach. Here's -1.3, here's -1.2, -1.1, you see where I'm going with this. I'm approaching from the left. So this is from the left of f of x. I'm sorry, not f of x, but g of x. The question is, what is this function approaching? right? As I plug in numbers that are closer and closer and closer to -1, are my y values approaching something, right? And as you look at these y values, like 0.5, then 1.2, then -0.4, then positive 0.07, then -0.03, it doesn't really feel like they're getting anywhere. Like, it doesn't feel like they're approaching it. In the last problem, we were really getting closer and closer to 15. This one, it doesn't seem like we're getting anywhere. And so when that happens, we'll say this limit, I mean, it doesn't actually equal anything. We say that this limit, and I'm actually going to type it, this limit does not exist. And that can happen. I mean, if your values are not approaching something, then the limit does not exist. Okay? Okay, so I've got one more example for us to look at. I want us to consider the table of values below for the function h of x. And again, I want to know what limit is being indicated by the table. And in fact, I'm going to change my instructions there. I want you to write 3 limit statements for this problem. I believe you should be able to write 3 limit statements here. One that's a left-hand limit, one that's a right-hand limit, and one that's a double-sided limit. So pause the video, take a minute, and figure out what those 3 limits are going to be. Alright, so in this table there's a 3 in the middle. It sort of seems like some of the numbers are leading up to 3 from the left, some are leading up to 3 from the right. And so what we can probably do is we can probably write a left-hand limit, a right-hand limit, and a double-sided limit. Right? So let's first start with the left-hand limit. That would be the limit as x approaches 3 from the left. Right? So if you haven't written a limit for this one yet, if you didn't recognize that, take a minute now and write down what this limit is equal to. Right? Well, when I approach 3 from the left, when I plug in numbers to the left of 3, like 2.8, 2.9, 2.99, it looks like these y values are approaching 2. So I'm going to say that my left-hand limit is 2. Now my right-hand limit, on the other hand, when I look at the limit as x approaches 3 from the right, and those arrows are really kind of ugly, sorry about that, that x is pretty bad too. So as x approaches 3 from the right of h of x, well, when I'm approaching from the right-hand side, my y values, I've got -0.19, -0.195, -0.199. It looks like I'm getting closer and closer to -2. Right? So it looks like the left-hand limit existed and the right-hand limit existed. So now, what is the double-sided limit? What's the limit as x approaches 3, not one-sided? Okay? Now, the wrong answer is 0. You don't say, oh, well, one was 2, one was -2. Hey, they average out at 0. This limit, this double-sided limit, because these two things were not equal to one another, because these two statements were not equal, it means that my limit down here does not exist. Okay, so again, if you're ever in a situation where you've got 2 one-sided limits and they're not equal, that means that the double-sided limit does not exist. It will never exist if the 2 one-sided limits are not equal to one another. So that's basically how we find a limit numerically. In these cases I gave you the table. In other cases you might have a blank table that you'll need to fill in and then make these judgments, or you may have to come up with the table entirely on your own. This method is the numerical method for evaluating limits.